Okay, so welcome back to another video. Here we have nested radicals. So this is written as 3 plus the square root of 3 squared plus the square root of 3 to the 4th plus the square root of 3 to the 8th, so on and so forth. And so you notice that with the patterns of the nested radicals, the exponent actually doubles. So here we go to 2, double when we get to the next radical, 4, 8, then 16, and then 32, so on and so forth. It doubles, in other words. Probably looks hard at a glance, right? But if we take a look at this in specifically, if you think of this like a continued fraction where the denominator just infinitely just keeps repeating itself on and so forth, we can actually make this a little bit easier to do the evaluation. And that's generally how especially if you want to solve equations, or rather solve or compute some value in the form of some nested or continued fraction, nested radicals, however you want to see it, infinitely continue, so on and so forth. That's usually the approach, and generally the way that you want to take a look at things from the situations as that. Not that much from there. The way you see this is more like if we can create some sort of quadratic equation, and then from there we can actually solve the value of what we're trying to achieve for. So let's actually just jump right in. Now suppose that I'm gonna write this same thing again. So 3, then square root of 3 squared, add this with the square root of 3 to the 4th. I'm not gonna write the whole thing, so I'm just gonna stop there, and then so on and so forth. So it repeats. Suppose that if we actually set the equation as 3 plus x. So in other words, it's setting the equality. So in other words, we have that x is going to equal this nested radical. So if we take a look at things a little bit interestingly, so suppose that if I were to divide 3 to x being our nested radicals that we're taking a look in careful consideration, so that would mean that we have 3 squared, then square root, or 3 to the power 4, so on and so forth. Okay, all this being divided by 3. So we looked at things a little bit carefully. So this is actually, all this is being divided by 3. So we can actually move the 3 back inside of the radical expression, but that would have to mean that you have to take this until going into reverse, and that would be 3 squared. If you think about this 3 squared on the denominator inside that radical, you take that out, then it goes out to the 3, hence what we have this result. So that means we're gonna have 1, then add this with this cube, or the 4th root of or 3 to the power 4, and then all the way so on and so forth, divided by 3. And then if you actually repeat this, you do this again, so that means we're gonna have the square root of 1, add this with the square root of 1, and then add this with the 8th, 3 to the power 8th. I'm saying roots because there's a lot of radicals. Okay, so if this just keeps on going, then if you repeat this iteration, so on and so forth, then you'll notice that everything is just going to be the square root of 1 plus the square root of 1 plus the square root of 1, and then it just keeps going on, so on and so forth. Again, this actually has that very nice, pattern. As long as you take this into, consideration after you put the 3's back into the inside the radical as you're going in reverse, instead of taking it the square root into that consideration. So that would actually have to mean that if we follow this little pattern, that x to the power, or x divided by 3 is going to equal this continue nested of 1 plus. So let's actually just underline what we have establish. So what I can do is, again, we see that this is actually just repeats. So in other words, the square root of 1 plus square root of 1 plus square root of 1, we can actually sub back the x over 3 into this starting place over here. So we actually form ourselves a little equation that it actually looks a little bit easier to, work with. It's not as tame. Well, okay, so now we're gonna have the square root of 1, then plus x over 3. As we see that if we set that x over 3, it is equal to this. It's just a plus and repeats. And so from here, we can actually just solve this out easily just using some, simple algebra. Square both sides. So I have x squared divided by 9. Let this equal to 1 plus x divided by 3. Okay, then we just solve this out like a quadratic equation. So it's x squared divided by 9, subtract x over 3, and then subtract 1 equals 0. Let's actually just get rid of all those fractions. So we have x squared minus x, or excuse me, this is supposed to be a 3x, and then minus 9. Let this equal 0. Okay, so this is actually not that it's not possible to actually, factor this out easily, but no worries. At least we have the quadratic formula. Just write this for anybody who's forgotten. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so then we just plug in everything for a, b, and c over here. So that means x is going to equal 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 9. All this divided by 2 times 1. A is equal to 1. Then if we simplify this out further, so this is 3 plus or minus the square root of 9 plus 36. All this being divided by 2. And so therefore we have that, simplifying this out even further, we have 3 plus or minus 3 times the square root of 5 divided by 2. Okay, so we have two solutions. However, if you were to plug both solutions back into the equation over here, only one of them works. The negative solution actually does not work in this situation, so we have to completely omit that. And so therefore our only solution is going to be x equals the positive of 3 plus 3 times the square root of 5 divided by 2. So let's put that back in. So x is equal to 3 plus 3 times the square root of 5 divided by 2. And so with just like that, all we have to do is just plug this back into what we established the equation where we said 3 plus x. So we just substitute that in. So let me put this in terms of our given. So 3 plus the square root of 3 squared, add this with the square root of 3 to the power 4, add this with the square root of 3 to the power 8. Then just plug this back in for equals, let me actually just put this on the next line. It's going to equal 3, then plus x, substitute that x that we just solved for, 3 plus 3 square root of 5 divided by 2. Put this into like a little common denominator, so it's going to be, 6 plus 3 times the square root of 5 divided by 2. And so therefore we found that the value of this completely continued nested of radicals is going to equal 9 plus 3 times the square root of 5 divided by 2. And just like that, we are done. And I think that there's, I'm pretty sure there's a general, if we're looking this in terms of like, any general case of numbers instead of 3. So maybe for example, if I say that this could possibly work for all real numbers, if you think about this, because all these exponents are, even. So we don't have to really consider like what choices of numbers such that, to the point where the radical becomes undefined. So if you just let me know if there is a closed form of this, then that would be awesome. And so just like that, we are done. So yeah, that's pretty cool if you ask me.